Hi everyone, this is the revision paper on magnets, and I'm just going to go through the last two questions, the open-ended questions of this paper. So let's look at question 6. Diagram below shows a method used in recycling centers to separate magnetic metals and non-magnetic metals. Okay, so take note here, the purpose of this is to separate magnetic from non-magnetic. Okay. So I have a mixture of metals that is poured into the moving belt. Right, so I've got a mixture here that's poured in. So what's going to happen is this will travel down. Okay, and if I'm non-magnetic, I will remain here and I'll zoom, go down here. Now, but if I'm a magnetic fella, so I'm going to get attracted, I'm going to whoop, go up here. And I'm going to continue down and wee go down here. So that's how I get separated. So this will be all my magnetic materials and this will be all my non-magnetic materials. So your job is to explain how the magnetic materials are picked up by the moving belt X. So this is actually quite obvious. The reason for that is because if you look here, X has a very strong magnet. Okay, so I've got a very strong magnet in X. So like I said, if I'm a magnetic material, when I get caught down here, the moment I reach somewhere here, this magnet is going to attract me and I'm going to move up. Okay, so I'm going to move up, I'm going to get attracted and I'm going to move, and then slowly at this point, because I'm going to be further and further away from my magnet, the magnetic strength is weaker and boom, I will drop in. Alright, so this is how you explain your answer. So when a mixture of metals on belt Y passes belt X, the magnetic metals will be attracted to the magnet in belt X. So the keyword here is it will be attracted. Okay? So now the next part here is supposed to explain how the magnetic metals drop from X to bin A. So like I said, because when they move here, the magnetism or the magnetic force gets weaker or it's not strong enough to attract the magnetic materials. Okay? So your answer should look something like this. At the end of belt X, the magnetic force is too weak to attract the magnetic materials. Right, let's look at question 7. So this person set an experiment as shown below. He used a spring that when it is stretched, it lengthens, and compressed, it is shortened. Okay, so then he has this setup. So I got this retort stand, I put a magnet here, I put a cardboard here, and I have the object that's being tested. And so he measures the length of the spring. Okay, so what he did was he tested an object made of glass. So you see here glass, together with 4 different objects, A, B, C, D. Now they have the same size and same mass as the glass. Okay, so you observe the changes in the length. And so if you look here, when he put the glass in, the length decreased, means it dropped down by 3 cm. Why do you think this happens? Why do you think when I put the glass, the spring gets shorter? What do you think? Yeah, because the glass is heavy, it has a certain mass. So when I put something on the spring, obviously you should know that the spring will go down. It will get shorter because my spring is being compressed. Okay. So then they ask which object is definitely, keyword here, definitely a magnet. So recall concept. How do you know whether something is definitely a magnet? We test for, what do we test for? Yes, we test for repulsion, repelling. So what happens if, let's say this is definitely a magnet, it's going to repel. When it repels, what direction is it going to go? It's going to go down. Okay, because it repels, so it's going to go down. If it's attracting, it will go up. Okay, so if it's attracting, means the length will get longer, but if it's repelling, the length will get shorter because it's going to be pushed down. So which is the one that will be definitely a magnet? Yes, you look here, D. D is the one that's definitely a magnet. Alright, and your reasoning is because there's a repelling, and a repelling will cause a decrease in the length of the spring. So it will look something like this. Alright, so object D, magnets will repel and cause a decrease in the length of the spring. Now after that, Hari assumes that object C is made of copper. Is he correct? Explain your answers. Now let's look at C. C is here. C has no change. Now let's recall copper. What is copper? Is copper a magnetic or non-magnetic? Yes, copper is non-magnetic. So please take note of that. Copper is non-magnetic. So if it's non-magnetic, is it going to increase? Is it going to be attracted? No, it's not going to be attracted. So it's going to be like the glass. The glass is not magnetic. And if the glass is able to cause the spring to decrease by 3 cm, then copper should do the same. But if you look at C, copper has no change. So that's why your answer is... So no, placing an object on the spring will shorten the spring. So this is the first key concept. Placing an object on the spring will shorten the spring. So this will give you your first half mark. So now then, since copper is a non-magnetic object, so that will be your second half mark. There is no magnetic force of attraction pulling the object upwards. Okay, so because it's non-magnetic, there is no attraction, right? Basically there's no attraction. So that's your third half mark, and your final half mark is to say that the length should be shortened. Okay, just like the what happened in the glass. Okay, right, hope you understand, and if you have any questions, please don't be shy to ask. See you.